Today we're looking at our final piece on ellipses, and I'm going to start with reviewing a question similar to ones that we've already done, just to be really clear about the steps. If you feel really confident about this one, you can just fast forward to the next step if you like. So we're going to graph and locate the foci of this ellipse, and the first thing we're going to do is decide where its center is. So the center then will be at, and remember we're switching the signs here, so the center will be located at +3 and -2. And we can plot that point right away if we like. Then we need to look at our A and B values. So A is the larger of the two here. So A will be the square root of 64, and so it'll be ±8. Which when the ellipse is centered at 0, 0, gives us the values -8, 0, and +8, 0 as our major vertices. Now, because it's not centered there, those are not the actual locations of our vertices, but we can use the center as a mapping rule. So you could think of the mapping rule as being x, y, any original piece or any original point on the ellipse that's centered at 0, 0 will map onto x +3 and y -2. So we're adding 3 to all the x coordinates and subtracting 2 from all the y coordinates. So that would give us as our major vertices -5, -2, and 11, -2. So -5, 1, 2, 3, 4, 5, and 11. I'll have to just eyeball that one. And then our minor vertices are from the B value. We've got 36 there, so B will be the plus or minus the square root of that, so ±6. So that would give us 0, +6, and 0, -6 as our minor vertices. But if we apply the mapping rule, we add 3 to the x coordinates and subtract 2 from the y coordinates. We get these 2 points for our minor vertices. So over 3 and up 4, and over 3 and down to -8. Okay, so then we can sketch our ellipse. And remember that whenever we graph this, even without saying it, we still need to locate the foci. So our c squared is a squared minus b squared, so 64 minus 36, giving us c is equal to the square root of 28, which will be 2 root 7, which is approximately 5.3. So if we think about what the foci would be centered at 0, 0, again, A is along the x-axis, so they're going to be the horizontal distances, so it would be 5.3 and 0, and -5.3 and 0. But then if we apply the mapping rule, and that's why I'm using the arrow here in all 3 of these cases here, just to show that I'm applying the mapping rule to that. So I'm adding 3 to the x values. So I've got 8.3 and subtracting 2 from the y values. Adding 3 to the -5.3 will give me a -2.3, and subtracting 2 from the y gives me a -2. So I'm at 8.3 and -2, and at -2.3 and -2. So there are the foci located on the graph as well. Okay, so there's not a lot of writing, but by using by stating where the center is, writing the mapping rule. Okay, and then you can use the terms, if you use the terms A, B, and C, you're clearly stating that you're working on your major vertices, minor vertices, and foci. So you don't actually have to write them out, but you can if you wish. Instead of showing this calculation for A, I could write major vertices, write down the original ones, and write down the new ones, etc. Okay, so be very methodical here so that you're making sure that you're getting the vertical versus horizontal done correctly, and that it's very clear to anybody looking at your solution what the actual coordinates of the points will be. Okay, let's look at a second example. The next two examples are ones that are just a little bit different so that you recognize how to handle those, okay? So in this example, I've got x squared over a quarter plus y squared equals 1. So clearly in this one, nothing is being added or subtracted to the x or the y before squaring. So our center is at 0, 0. Okay, our a squared and our b squared. Okay, now under the x squared, we've got a quarter. Under the y squared, you could think of that as being a 1. So we think of the larger of those two as being our a squared. So a squared is actually equal to 1. So a will be equal to plus or minus 1. Okay, which would give us vertices because it's under the y term. Our vertices are vertical, so they'll be at 0, 1 and 0, negative 1. Our b squared is 1 quarter. So b is the square root of that, which will give us plus or minus a half. And since that's under the x, the half goes in our x coordinate position, so it'll be negative a half, 0, and positive a half, 0. And then we might as well calculate c squared right away. So c squared will be 1 minus a quarter, a squared minus b squared. So c squared is equal to 3 quarters, and c then is equal to the positive or negative root 3 over 2, which is approximately equal to 0.87. So that would give us foci at, since it's vertical, 0, 0.87 and 0, negative 0.87. Okay, so that's harder to sketch on a graph to show the differences. So either you would on your graph make sure it's a large enough one, or you would change your scale. So I'm going to change my scale by just ticking at every second square along here to show that those are my, it's 2 squares for each full unit here, okay? So my major vertices are 0, 1 and 0, negative 1. My minor vertices are at negative a half and positive a half, and my foci are at positive 0.87 and negative 0.87. And so here is my ellipse. Okay, and if you've got space, put in the numbering on your graph as well. So that's 1, 2, 3, 4, negative 1, etc. Did I do that correctly? No, I did that. I'm going to press pause here and just think this through a second, okay? Okay, the mistake I made here is in labeling these. Let me fill in the rest of my ellipse. I'm happy with the way I drew that, just not happy with the way I labeled my axes. This is 1 and 2 and -1, and -2. So this is 1 and -1, etc. So every 2 squares was a half. Okay? All right, so let's move on to the next problem here. So the third problem, we've got x plus 3 squared over 16 plus y minus 2 squared over 16 equals 1. So where's the center on this, first of all? The center will be at -3, +2. So we can think of this as having a mapping rule of x minus 3. Sorry, I should start the mapping rule properly. xy maps onto x minus 3, y plus 2. So that's the little formula for calculating any of the vertices that I need to deal with. Now, next would be our a squared. Now notice that under the x term and under the y term, we have the same number. We have 16 for both. So we might as well just let a squared be 16. A will be plus or minus 4, which gives us as our original vertices, if we think about it as being under the x, we'll have -4, 0, and +4, 0. And once we apply the mapping rule to that, we'll subtract 3 from the x's, so -7 and 1, and we add 2 to the y's. So there are our two major vertices. And then our minor vertices, well, we might as well call B also to be 16, and we'll think of that as being under the y. So B is equal to plus or minus 4. So that would give us the point 0, 4 and 0, -4. And once we apply our mapping rule, we're subtracting 3 from the x's, so they'll both be at -3, and adding 2 to the y's. And our foci, c squared is equal to 16 minus 16, a squared minus b squared, c squared is equal to 0. So we're actually getting only one foci, or focus rather, okay? So let's plot these points and then we'll see what's actually happened here. Our center is at -3, +2, and we've got vertices at -7 and 2, and at 1 and 2, and we've got vertices at -3 and 6, and -3 and -2. So really what's happened is that this ellipse is neither horizontally stretched nor vertically stretched. It's actually a circle. The distance horizontally from the center is the same as the distance vertically from the center. There's only one focus, which is actually the center. Okay, so this is a circle, which really is a special type of an ellipse and leads us to this, the standard form for an equation of a circle. So instead of having the x and the y over a value, instead, we have x minus h squared plus y minus k squared equals r squared, where r is the radius of the circle, and the center is at hk, which makes sense from what we know about ellipses. So let's take a look at this new question where we're sketching the graph of the circle x minus 3 squared plus y plus 4 squared equals 9. So the center of this circle is now at +3, -4. So we can plot that point. Just move that up and out of the way. So +3, -4. And the radius will be the square root of 9, which is 3. So if we needed to, we could think of having vertices, but really, we don't really need to do that because if our radius is a nice whole number like 3, we can plot our center and then just go 3 in four, in 4 different directions, so up, down, and left and right, and there we have 4 points with which to sketch our circle in, okay? And again, it's very hard to make a circle look exactly like a circle, but try to keep things rounded at the vertices or whenever you're taking a corner, try to keep it rounded and it will look pretty good. So there's our circle. Okay, so here we have, we're starting with a description and we need to come up with the equation of the circle. And remember the equation is x minus h squared plus y minus k squared equals r squared. So we'll just substitute those into this equation. So we'll have x minus 9 squared plus y minus negative 3, so that becomes plus 3 squared equals 7 root 2 squared. The left side of that equation is already in the form we would like to see it in. So if we do 7 root 2 squared, let's just recall how to do that. So 7 root 2 times, think of it as this, 7 root 2. So the 7 times the 7 gives us 49. Root 2 times root 2 gives us 2, so that gives us 98. So the r squared is 98, and we have x minus 9 squared plus y plus 3 squared equals 98. And our final example is to write the equation of this circle in standard form. And we need to find its center and its radius. So this is like one of the questions that we did with ellipses, and we need to recall how to complete the square in order to do that. So we want to get it into that standard form. So if you think about what we did with our steps, and maybe you've written up a cue card for that, we're going to follow those same steps. So our first step was to group the x terms together. Group the y terms together. And add or subtract whatever we need to on both sides of the equation to have our constant on the right side. Then we'll take a look at the x terms and decide what do we need to add to that to make that into a perfect square. And remember, we take the coefficient of the x and divide it by 2 and then square it. So that then we can say x squared plus 4x plus 4 is now a perfect square. And we'll do the same with the y. So half of 2 is 1. 2 squared gives me 1. So I'll have plus y squared plus 2y plus 1 equals. Now here I've added a 4 and I've added a 1. So that's 5. So we need to add the 5 here too. So that will be 20 plus 5. So now we'll factor these out. We'll factor these to express them as perfect squares. This becomes x plus 2 squared plus y plus 1 squared equals 25. So now we can state that the center is going to be at negative 2, negative 1, and the radius is equal to 5. And that's it. That's our final little lesson on ellipses.